Okay, this video is to review our properties of exponents. This should be a review, so if I go too fast, feel free to pause it and rewind it. So if you have matching bases and you are multiplying those together, you add the exponents together. If you have matching bases and you are dividing, you subtract the exponents. And if you have anything raised to a power that's raised to another power, you multiply the exponents. Super quick. I don't like using A's. X cubed times x squared. The reason you add those is because you have 3 x's and 2 more, so if you add it together, you get x to the 5th. X to the 7th over x cubed. The reason you subtract those, 4, 5, 6, 7, is that you're canceling them out one by one. So if you cancel out 3 of them, you end up with x to the 4th left over. And then if you have x squared cubed, you really have x squared times x squared times x squared, right? 3 sets of x squared, which is why the answer is x to the 6th. If while you were doing that, you got a negative exponent, so if it was x to the 3rd over x to the 7th, that subtraction rule is going to give me x to the negative 4, but that's because all my x's would be on the bottom when they simplified. The only x's I'd have left would be on the bottom. So that is why negative exponents on top go to the bottom as positive. And if it was 1 over x to the negative 3rd, negative exponents on the bottom go to the top as positive. Anything raised to the 0 power is 1. And if you have the nth root of x to the n, the nth root of a to the x, the power, the top number is your power, and the bottom number of your fraction is your root. So we are going to use this to simplify. One thing about exponents, well, first of all our answers need to be positive. But as they get more complicated, there are more than one way to do them. I try to recommend the easiest way, but you could do it another way and get the same answer. So in number 1, I'm going to combine the top first. X times x, that means add the exponents. 12 plus negative 4 is 8. Then the negative exponent rule says I move those to the top. You don't have to show all this work because there's more than one way to do it, and some of this you can do in your head. If I move it to the top, I'm going to add them together. X to the 11th is going to be my answer. Number 2, notice the plus sign. We can't do anything. It's not quite the same when there's the plus sign. But remember, from all of our fraction work, we can separate those. So it's x to the 7th over x to the negative 5 plus x to the negative 3rd over x to the negative 5. Just common denominator, right? Now simplify it. These 5 go to the top, and that gives me x to the 12th. This one's bigger, so if I put those 5 to the top, negative 3 plus 5 more is going to give me x squared. The exponents don't match, so you cannot combine like terms. They are not like terms, so there's nothing to combine. Okay, turn everything into exponents, so we don't like roots. So the 4 is just there. The 4 is part of the answer. That's not going to change because there's no other whole numbers in this problem. But this one has an imaginary 1, and it's cube rootings. That's x to the 1/3. I'll put the little dots in between. This one, 2/5, x to the 2/5. This one, imaginary 1. When you don't see any number on the root, that's an imaginary 2. So x to the 1/2. Matching bases being multiplied together, the rule is that we add these together. Common denominator is going to be 30, so times 10, 10 over 30, plus times 6, 12 over 30, plus times 15, 15 over 30, 27, 37 over 30. So 4, x to the 37 over 30. Or if it was multiple choice and for some reason it wasn't written like that, 4 times the 30th root of x to the 37. Sorry, my screen was zoomed in. I just realized that I started with number 5. Let's go back to number 3. So we have a parentheses again with a minus sign. So the first rule is just distribute. So again, I'm going to write a little more than you have to write when you actually do your work. I'm going to distribute the xy to the negative 2 to the first term. and the problem says minus, I'm going to distribute that to the second term. Okay, then x to x is going to be x squared. Y to y is going to, when I add them, they become 0. Y to the 0 just disappears. There are no y's. Problem says minus. X to x, there's no x. The 3 is the only whole number. Y to y, this is my answer. Okay, I did number 2 a second ago. We were able to split the 2 because the denominator had a single term in it. You cannot split number 4 because the denominator has a minus sign. So instead, we're going to turn everything to fractions and do that thing we love. I told you we're going to do it like in every chapter, at least every semester. Turn each of our negative exponents into fractions. Then we're going to multiply to get rid of all the fractions. So common denominator is x. Everybody gets multiplied by a red x. The rule is that our answer needs to have only positive exponents. That's why we're doing this. Those go away and you have a 1. Those get multiplied together, you have a squared. Those go away and you have a minus 1. That has only positive exponents. That's a good answer. Okay, then I did number 5, 6, and 7. Okay. When you have more than one thing happening at a time like this, you have choices, but exponents need to be done first. So before I can do anything with like top and bottom, I need to do the exponent that is only on the top. So we're going to cube everything. Remember, whole number math has not changed. 2 cubed is 2 times 2 times 2, which is 8. Power to a power is multiply. Just keep your negative. Power to a power is multiply. I have not changed the bottom. Now what I like to do is get rid of negative exponents. Also, you can reduce 8 and 14, right? 2 goes into both of those. Reduce that like a regular fraction. Divide by 2, divide by 2. I need a longer bar. Okay, move my negative exponents to the other side. So I've got 9x's here and I'm adding them to the bottom. 7 and 9 is 16. I have negative 3y's here, so I'm moving them to the top. 15 and 3 is 18. This is our answer. Number 7. Okay, so see how this is to the negative 2? Let's deal with that first. So I'm going to leave the other piece alone for now. Let's write it down. Well, we can simplify that as we go. So 8 and 6, those are divisible by 2. 4 and 3, so 4 over 3. And then same thing as problem 6. Move your negatives to the other side. X to the 13th. Subtract your y's, you'd have y to the 4th left. And now let's deal with the part that's complicated. So first, I'm going to do the inside. So I have x to the negative 10 on the top. I'm going to move those to the bottom. So I have not dealt with the negative 2 yet. All of those x's go to the bottom, which leaves a 1 at the top. There's a 9 in the problem. I'm adding 10 more x's to the bottom, so I'm going to have x to the 11th, y to the 5th. Then, I'm not changing this part right now. When you see a negative on a whole fraction, that means flip the fraction over. Right? That's what a negative does. You can put it over 1, but it's not necessary. And that got rid of the negative. Now I'm going to do the actual squaring part. I still haven't changed this. Now square everything. So 81, x to the 22nd, y to the 10th. That's kind of messy, but that's fine. 3 goes into 81 27 times. Y to the 13th on the bottom, y to the 10th on the top. Oh, wait. When did it become a y? Sorry, this was an x. I said we weren't changing it, and then I went ahead and changed it. Okay, so 4 times 27 is 918, in case you didn't know that. I have x to the 13th on the bottom and x to the 22nd on the top. 22 minus 13 is going to give me x to the 9th. And then I have y to the 4th, and 10 more. It's going to give me y to the 14th. Just take it one piece at a time. Remember, you can't combine anything if it's still in a big parentheses. So big parentheses need to be handled first. Okay, Euler's number E. E is the base of a natural log. So if you ever see this natural log, it's Latin or something. That's why it's LN. I know it doesn't actually spell natural log like that. There's a little, you know how in integrated 3 you learned that if we just write like log of x and there's nothing there, there's a little subscript of 10 because we do base 10. Well, if you see a natural log, there's a little subscript of e. And e is, it's kind of like pi. You know how pi is 3.14 blah, 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 and it goes on forever? Well, e is 2.718 blah, 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 and it goes on forever also. But to make it exact, we just use the symbol e, just like we just use the symbol pi. So it's often used in continuously compounding interest. So you can see the formula there. P is the principal, how much you start with. E is Euler's number, but there's a button for it on your calculator. R is the annual rate, T is time in years, and the answer is your ending amount. So if we look at number 2, we have $4,729 invested at an annual rate. So P was that amount times E. The annual rate is 2.9%. Make sure you move the decimal twice. So that's 0.029 times after 13 years is the question. If you type that into a calculator, you will get $6,894.43 because in money, they always round up. And that would be the answer to number 8. Okay, so just a quick review of exponents. I hope you guys are doing good.